Hi, welcome back. We are talking about the game of Go. The game of Go is a fun game, but also a really important game in the history and development of computer science. And even just recently, it's just been a tremendous fight for computer science to learn how to make a computer play Go. And you can actually download some apps that actually use the AlphaGo system for the computer AI. Um, so it's pretty exciting stuff to see the future computer science develop while playing an ancient board game. So we are going to make this in Greenfoot, and we are not going to handle all of the little bitty nuances because there'll be some things that we can improve on, but we're going to handle most of it and make a very playable game. This is the structure of our classes. We're going to have the world class from Greenfoot that we're going to subclass with a game called Go, and we're going to subclass actor with the spaces themselves. So the spaces of the board are going to be actors. And we're going to make a stone class. And notice I don't have a picture for stone. I could add one, but it's not necessary. The stone is actually going to handle some of the code for us so that we don't have to write all the code in black stone and white stone. Subclassing, when you know that you have two classes that are going to behave really similarly in lots of ways, except for maybe one tiny little difference, being that one's a black stone, one's a white stone, it's a good idea to make a class, even if that's a class you don't plan to actually use directly, that it can handle a lot of the code for you so that you don't have to work and make your code all in one class and then copy it over to another and end up debugging it in two places. And this is just a better way to make that happen. So we're going to make kind of an abstract class sort of here that we're not actually going to use, and then we'll subclass it with blackstone and whitestone. Okay, so uh, let's get that. That's kind of the overview of the class and how it's going to work. Hopefully by now you've downloaded all of the different images that we're going to be using, and you can copy those images into the image folder once you make a once you make this world here. You can actually just go ahead and copy those images into the folder. So I've called this project, you should probably call it lowercase go for Go. I'm calling it Go Demo 1 because I've got lots of Go's in here as I've worked through developing this project. Um, let's go ahead and see where that would be. For me, that folder, let me navigate to that right quick. Okay. For me, that folder is here. And you'll see that it's made these different projects here. There's our project main file there. Um, well, currently we have a My World class that we're working on. I'm going to go to images, and I've already selected all my files and hit copy, and I'm just going to paste them there. So they're all going to be available for me right now, just like that. Okay, and there we go. Okay, so back to the Greenfoot. The first class that I want to work on is going to be this class Go. So I'm going to click on My World. My World is not a very good description of what this class is, so we'll just call it a different name. Let's just call it Go. And classes need to begin with a capital letter, and notice it's subclasses world. Okay, and these are our documentation. This is really important. You need to fill this in considerately about what you're doing. So let's write a description. This is here is this is the class for making the Go board and controlling game flow. All right. So this is going to be the class that we use to kind of control whose turn it is and how things work. All right. So, and we've changed the title, so we need to change the constructor. There's the constructor. Oops, not that. So the first thing I want to do for this class is I want to make a constant. We're going to use some constants today, so let's make a couple of them right now. And Some of you have made these before, others of you have maybe not made them. So let's just write down the code and then we'll talk about what it means. And I will add a comment to explain what this constant is. This is for a 9 by 9 game. And that's a private comment. So no one's going to see that when they go here to our documentation, okay? They will see they will see what's called a field summary. So these constants are called a field. You'll notice it doesn't even tell me that it's final, but I can tell that it's final by that it's all capitalized. So you see game size there, and now it tells me that it's final. So we have just a private comment there, but we should probably go ahead and make it a public comment that appears in our documentation. And we do that by putting a slash and then 2 stars. And that becomes a multi-line comment. If you erase one of the stars, you'll notice it turns gray. That's still a private comment. It just lets me have multiple lines to do it. But I want this to be a public comment that appears in my documentation. So I'm going to do that. The size of the board, that's what this sets. Or I could say the length of one side of the square board. So we see that this is actually a 9 by 9 sized board. Okay. All right. Let's make another constant. So public static final int info column size equals 3. A 3-cell wide info column. And I'm not going to make, well, I could make that one public as well. I could give it a public comment, but I'm not going to right now. So let's talk about these constants just a little bit. Notice, first of all, they're written in all capital letters, and we use the underscore to separate words as opposed to a camel case. That is a good coding style. Whenever we make a constant, we want to tell our readers that it's a constant immediately by using all capital letters. What makes it a constant is this word final. Final means you cannot change it later. So if I were to go here and say, you know what, I want to change game size, I want to increase it by 1, I'm actually going to get an error. I'm going to get an error because I told Java, you'll see the error says, cannot assign a value to final variable game size. I told Java right here when I said final, that I don't want to change it. So that word final is really just kind of telling Java, hey, help me code, make sure that I don't accidentally change this later, because if I change it later, it would mess up the game. It would totally break the game. So it's just putting the word final is a good way for me to make sure I don't make a mistake. I could also keep it a constant by simply not changing it, but that's not a good idea. We want to put the word final there. All right, next you'll notice that we have this word static, and we are slowly starting to talk about what static means. Static is one of the more confusing concepts of Java, but it is a very important one. So we are using a static constant here because it's just a huge advantage. I'm going to be using these values in the lines of my constructor, and the first line of my constructor needs to be a call to the superclass world constructor, and I can't make that the second line. It has to be the first line of my constructor. So I need to make sure that I have game size, since I'm going to be using it in my constructor, and info call size. I need that to be initialized before I use my constructor as well. And I'm not allowed to say, okay, let's make sure game size equals 9, right? Let's put that, and then let's make sure and then put it there. I'm going to get an error because I no longer have call to super must be first statement in constructor, right? That's not allowed. So I don't have the ability to initialize the variable in the constructor like we're used to. I need to do it here. And so you see that we actually not just declare the variable, we actually assign it one as well. But the static members of a class are created before instance members. And so I know that's a little confusing, okay? But the class, the purpose of a class is to make an object, right? So when you make an object, each object is assigned different properties and variables. But static members are made before any of that is going to happen, okay? So essentially, to make a long story short, this line of code must be executed before the constructor. So we know for a fact game size is not hanging in limbo and undefined. If I remove the static, now we have an issue because this is not going to be created until the constructor is made. And so, see, the game size is not ready. Is basically what it's saying. It's saying, look, here you are trying to create an instance of Go, and you're using game size, but I haven't actually set it yet, even though I set it here, right? But by putting the word static in front of it, then I'm saying, hey, make sure you assign game size 9 before you go here, all right? Remember, in Java, inside a method, things go in order from top to bottom, but outside of the methods in the class, what determines the order is not where it is. I could put these lines of code at the bottom of the class, in the middle of the class, wherever, okay? What's making it happen first is that word static, okay? All right, one other thing. You'll notice that it's public, unlike the private instance variables we've been doing. That is the tradition, is to make final constants public. And the reason why is because we want to be able to access them easily and quickly from other classes, and there's no fear of us messing them up. We know that we make our variables private so that they're not accidentally changed in some other class. But by making a constant public is not a problem at all because it's final. No one has the right to change it even inside this class, much less somewhere else. So they're not going to be able to change the variable. We certainly could make it private, but it's going to be much to our advantage to keep it public. So those are constants. We want them public, we want them static, we want them final. And we write them with all caps. We assign them the variable when we create them, we assign the value to them, and we can't change them. Okay, let's start making our constructor. So basically, the game is going to work out kind of like this. So this here is what I call the game size. Okay, so we already saw that variable, that final variable. This is game size, which I'll just call GS. This is going to be our info. Okay, this is the info column size, right? And then because it's a square, this is going to be this here. Oops. My pen is going nuts. There it is. So this right here, this whole thing is the also the game size. Okay. So what I want us to do is I want us to make a constructor that it makes the game that size. So the first value is the how wide the game is, right? That's how wide it is. Let's take a look at that in the world class. So I'm going to bring up the world class. We don't look at the code itself. We just look at the documentation. So that's how wide it is, right? Well, I want this game to be pretty wide. I want it to be the game size, right? The board size plus the info column size. So I'm going to say game size plus info call size. And I know because of those values being static, I'm guaranteed that they have been already filled with numbers. So that's fine. And then the next thing I want to do is the game height. And you can see that this game height is just the game board size. So I'll just say game size. Okay. And then finally, we want to have, we need to say the size of the cells. So the way if you're using my pictures, I used 600 divided by the game size. So That's going to make those pictures perfectly work out right. We're also going to be able to shrink and enlarge our pictures, but that's going to be the easiest way. So I'm just going to say 600 divided by game size. So that way, what's going to happen is as the game gets bigger, if someone wants to play a 19 by 19 game, we're just going to make our cells smaller. So 600 pixels is really how big this is. So this will be 600 pixels. And so if our game size is 9, then we're going to be dividing 600 by 9, and that's how big each one of these individual cells will be in pixels. So the game can always be the same size on our window, but the actual cells themselves will get smaller as we need to fit more of them in. Okay. So I think that is pretty much it for now. But we need to go ahead and make one instance variable. So let's do that. And I like to list them below my constants. Now, an instance variable is private, okay? And it's what belongs to the instance. So this will be made at construction. And these variables are important because they change throughout the running of the game. The constants don't. And one of them that's going to change is whether or not it's black's turn. Oh, I forgot the type. So black's turn, it's either true that it's black's turn or it's false, right? Well, that's called a Boolean. So private Boolean, black's turn. And so now what I'm going to do is say black's turn is equal to true because in the game of Go, the person that goes first is always black. All right, cool. Let's make a couple of methods. We're going to add some more stuff to this class later, but we can't add too much until we've made some of the other classes without having to deal with a bunch of errors because it won't exist yet. So public Boolean is black turn. All right, and so that's just going to allow us to know from outside the class whether or not it's black's turn. So we just simply return black's turn. Okay. Now we need to write a method to change turn. So public void change turn. And for this method, we want it to change whose turn it is. So there's lots of different ways we could do that. We could use some if statements. We could use some we could use if statements. I could say something like if black's turn, then set equals true, then black's turn gets false, something like that. But I'm not going to do that. What I'm going to do instead is I'm going to say black's turn equals not black's turn. So if black's turn is currently true, then the word true would go right here. But what is not true? False. And so then black's turn becomes false. Remember, this assignment variable, the single equal sign, is done last when evaluating a line of code. If black's turn is false, then false goes here, and then but not false is true, so then we assign it true. So that's a very common technique for just toggling a Boolean. All right, we're going to leave the Go class for a little while now, and we'll come back to it later. The next thing I want to do is I would like for us to make the Stone class. So the Stone class is going to be an actor. So we'll right click on this and we'll say new subclass and we'll just say Stone. Notice that I've got my images that I put in there already so I can select them. I'm not actually going to select the stone though. I'm just going to say OK. And you notice that there's no image for it. And that's fine. There's no point to because we're not going to actually instantiate this class. All right. So the Stone class needs to have some constructors. So one of the things that's going to make this a bit challenging is that we want this game to be able to be expanded to different sizes. 9 by 9, 13 by 13, 19 by 19, or any size in between, which would be not traditional, but we want our users to be able to do that. And so as we do that, the stones need to shrink because there needs to be able to fit more of them. So we're going to be controlling the size of our different images throughout this project. Okay, so I'm realizing something. I made a mistake in my code earlier, and I forgot that we needed one more constant. And so before we do the Stone class, we need to fix that. So if you can go back to the Go class, and what I had was I had this right here. And the problem with that is that we need to be able to access this cell size in other constructors. So we need to have it again static so we can access it quickly and first thing get it initialized. So we need to do that. So what I want you to do is to write public static final int cell size. And 600 is going to be the number of pixels that will occur. And so I'll put that as a comment, 600 pixel wide or tall window. And so that we can make the window bigger by just changing that 600 if we need to. And then down here, let's go ahead and do good coding and use it. So, and that makes our code more readable as well. No magic numbers down here. Everyone can see that, okay, how we're setting up our game. Okay, so just a small little deviation. Now let's go back. What I need to do, let me erase that again. So we need to make a constructor for stone. So when we don't make the constructor, right, when we make a new subclass for stone, there is no constructor that we can see. But the experienced Java programmer knows that there is a constructor. It's there. We just don't see it because Java makes it for us. And that default constructor is completely blank and with a call to super like that. Well, the problem is that then we don't get to have any control over the specific size of our stone. And we want to be able to make the stone smaller. We talked about that. So I'm going to adjust that. I'm going to make a temporary variable called greenfoot image. So the greenfoot image class is a class that handles all the images that we have. We've been using it all the time, whether you know it or not. When every time you assign an image to one of these actors, you're using a greenfoot image. So I'm going to call getImage. So getImage is simply going to get the image that is currently assigned to this particular actor. And right now, it's just a blank image because we didn't assign it one, but when we subclass it, we'll have one. And we can now resize the image by saying image.scale, and I want to resize it to being the proper size. So we need the cell size. The way you get the cell size is go.cellSize. Static methods, which we haven't written yet, and static variables, these are static variables, are accessed not on an instance of the class, but on the name of the class. So I don't need to make some go object. I just say the name go.cellSize. And go.cellSize. So now my object will be resized according to the size of the game. But I have learned that this is actually a little bit too big. And I think, multiplying by about 0.65 to make it about 65%. So I won't do this in the other classes, but with the stones, I want them a little bit smaller than that. So I'm just going to multiply them by that factor. And we can go back and change that later if we feel like they're too small or still too big. Okay. So now when our stone gets made, it should be a more reasonable size that as we go from 9 by 9 to 19 by 19, we'll resize as need be. Okay. So now the next thing I want my constructor to do is I want my constructor to set an instance variable from double to int. Oh, well, we need to, the problem, it's telling me right now that we're using a double. That's okay. We can fix that. Let's just do times 65 divided by 100. Okay, so that was the problem. It was trying to change it into a double. We could cast it, but we need to make it an int. So let's do that. So that'll be like multiplying by 0.65. But now it's going to use integers. Okay. Basically, a stone is going to be either safe or not safe. So I'm going to make a Boolean variable called safe, and I'm going to set that to true, and it's just going to be true for a little while. So this is just for the time being. Once you create a stone, it's safe. Then the next thing we're going to do is actually detect whether or not that needs to remain true. We're going to do that in just a minute. This gives me an opportunity to discuss a very important concept, and that's the difference between instance variables and temporary variables. I need to change the size of the image. I do not need to keep a copy of this image that I can access in every method I write. But whether or not the stone is safe, I want to be able to determine that wherever I go. So you can see down here in this other method called act, I can actually say something like safe equals false if I wanted to, and this code will work just fine, just like it did up here, because I have declared it as an instance variable, meaning that that's a variable that is reserved to be used anywhere in the class. However, if I try and say image.scale, maybe like that, you're going to see I immediately get an error, and the error is going to be cannot find symbol. And I'm sorry that's such an unfortunate error because it causes so much confusion. I wish they would say error image is only defined in the constructor. I wish it said that. Wherever you put the type, you only put the type once when you create a variable. Wherever I put that type, that's me declaring that variable. I am declaring also its lifespan. The lifespan of Greenfoot image is just from here to here. I could certainly declare it out here, and then I can access it. I just have to say private Greenfoot image img, and then I have to remove it here because it'll actually let me declare it again and make I can have the same variable, count the same name, same type, but just in a smaller scope, and it'll actually use just a small scope one. And now it's no longer an error down here. But I don't want to do that. Why wouldn't I want to do that? Well, for two reasons. One, I don't want to do it because it's confusing to have every single variable you ever use. If you're only using a method, it makes your code a lot more readable, and it's just doing a little bit of work. It's not actually describing whether something important about the stone. And the other reason why, and I know as you get these bigger and fancier computers that this doesn't matter as much, but it is a waste of memory. Why would I want to allocate memory for a Greenfoot image to run for the entire life of the stone when I just need that memory for that one tiny bit of code execution? This is executed in a blink of an eye, whereas this it has to take up memory in the computer for the entire time that stone is active and being used. It's just wasteful. And I think memory maintenance still does kind of matter, especially as we program on small devices and things like that. So that's the other reason. Okay, so that was my discussion on that. Let's keep going. We are going to make several methods in the stone class. The first method that I would like to do is the mark for removal method. Public void mark for removal. So this mark for removal method will mark a stone to be removed from the board when it is identified that it is no longer safe. So this method will simply set the variable to be not safe. So what is the variable we use for safe? Just safe. I want it false. So I've marked for removal. Okay? And now I can do that. I can mark a stone for removal from any stone location, a subclass, or even a superclass. I can do it from anywhere because I have a public method for it. Next, I want to go ahead and make a getIsSafe. And I'm not sure. I really don't remember if we're going to use this or not, but it's just good to have it. We can tell whether or not this stone is currently safe. And I just return the value safe. All right, now we're going to write a method that's going to be a very important method for us. Public Boolean check liberty. So this is going to be the method that determines whether or not this stone needs to be removed from the board. This will be the method that can mark stones for removal. But I'm going to just say return false. Surprise, right? I'm not going to do any work here. And the reason why is because whether or not a stone has liberty depends on whether it's a black stone or a white stone. So I can't do it in just a generic stone class. But I need to have it declared. I need to have it declared here so that I can use it somewhere else. So I have to declare it even though later on I'm going to fix it. It's broken right now. But when we write black stone and white stone, we will fix it. So look for us fixing that. So this method is just to must be overridden in subclass to work. You know that we know how that is. We know that earlier. The act method is already written in the actor class, or else this wouldn't work. But it's just blank because it's void. They don't have to do anything. But this is Boolean, so I have to return something. But it doesn't do anything unless you override it. But in order for the code to work, it has to be declared in the superclass. All right, let's take a look at our method act. So this method's going to remove a stone. That's all this stone does. The act method just removes it if it's not safe. So if it's not safe, so if get is safe, and I could just access the safe method, but a safe variable, but I like using methods. So if it is safe, well, I'll tell you, how about this? If it is not safe, then I need to remove it. How do we remove an object? Well, we're going to, let's get a copy of the world, right? So I'm going to say world W equals get world. Okay, my actor, this is an actor, and actors have a get world method. And then the world has a remove object method. What object am I going to remove? I'm going to remove this stone that's currently being acted upon. So when we make a bunch of stones on the board, Greenfoot's going to go through one stone at a time, and each one it's going to call the act methods. And so if this stone is not safe, it is this stone that must be removed. So I put this. Else, can't run any more code after you remove an object, so make sure you use else. Now, if it is safe, what I want to do is I want to check the stone's liberties. So that's where I'm going to call the check liberty method. So I'm going to say safe equals check liberty. Okay, I can do it like that. I'm going to do it. I think that's a little confusing though. So I'm going to say if not check liberty, and I'm going to say mark for removal. Now I think it's a little bit more clear to readers of my code. All right, if you are not safe, you get removed. Else, we check if you need to be removed before the next turn. So we say if not, we mark you for removal. This only works because we've declared the code here. That's why we had to declare it. All right. So we've covered a lot. We've written our Go board class. We've got more to do on that. And we've written our action code. And we talked about how we have this Boolean that we had to write here, even though it's completely broken, so that we can override it so that it works properly. In the next video, we'll continue to work and build on the black and white stone classes and talk a lot about that check liberty method.